Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.8 entitled Ratios and Rates. And today we're going to write a ratio to compare two quantities. We're also going to find the unit rate for two quantities, and then we're going to convert. And a ratio and a rate are slightly different. A ratio is a comparison made between two quantities measured in the same units. So you're comparing apples to apples, the number of tennis matches to tennis matches. So you might have won 3 matches for every 5 matches that you played. Okay, so the units have to be the same. A rate is a comparison that's made between two quantities when there are different units. So this is where you might compare miles per gallon or dollars per hour. You might earn $15 for every 1 hour that you work. Okay, so a ratio has the same units and a rate has different units. You're basically making a fraction out of both of them to make the comparison, and you want to make sure that you reduce your ratios and your rates whenever possible. So for example 1 here, we're going to talk about our ratios. And here we have an archer, and he or she is shooting 60 arrows. And 44 of the arrows hit the paper target, and 16 miss. So we're going to write a ratio to compare the number of hits to total shots. So right here, that tells us what we're comparing. And when we read the problem, 44 arrows hit the paper target, and the total number of shots is the total number of arrows that were shot, so that was 60. So 44 out of 60. And we do want to reduce this, so that would be 11 out of 15. And if you wanted to label it, you could say arrows. Since it's a ratio, we're comparing the same units. 11 arrows for every 15 arrows hit the target. And for part B, we're going to write a ratio to compare the number of hits to misses this time. So 44 targets, or I'm sorry, 44 arrows hit the target. And again, 16 missed. That was told to us in the original problem. And we do want to reduce this. However, I don't want to make it a mixed number. I want to leave it a fraction. So it's going to have to be an improper fraction. When I reduce, I'm going to divide both of the numerator and the denominator by 4, so I'll get 11 over 4. And again, we could label that arrows. So for every 11 that hit the target, 4 missed. Now when we write ratios, we could also write them with a colon, so you might see that in the book too. You might see 11 colon 15 or 4, oops, I'm sorry, 11 colon 4. You might see the ratio written like that as well. That's not incorrect. That's just another way to write it instead of writing it as a fraction. But even if it's written as a little colon, we always want to reduce our ratio so that it's in simplest form. Okay, example 2 now, we're going to find the unit rate. So it's the same concept. We're still making a fraction, and we're going to reduce it, except now we're going to have different units. So we're going to find the unit rate for driving 70 miles in 5 hours. So you'd have 70 miles over 5 hours. And then you want to reduce that. We can divide both of them by 5. So that would give us 14 miles in 1 hour. So if that's how far you're driving, I don't know, that's pretty slow. 14 miles per hour? That's really slow. Maybe you're making stops along the way or something like that. We don't need to worry about implying the specific meaning so much. Okay, part B says we're going to pay $161 for every 7 shares of stock. So again, we paid $161 per or over every 7 shares of stock. So it's kind of like making a fraction as you read it. The first number is going to be your numerator, second number is going to be your denominator. And then we want to reduce. We can divide both of these by 7. So really we paid $23 for every 1 share of stock. That's a pretty good price. I don't think you could buy Facebook for $23 a share. Okay, and then the last one here, win 25 out of 40 games. So 25 wins out of 40 games that you played. Now, technically, you still won 25 games. So you could think of this as 25 games over 40 games. So this probably could still be interpreted as a ratio. But since it's a rate, we'll keep our units different here. And we do want to reduce again. We can divide both of them by 5. So we'll end up with 5 wins for every 8 games that we played. Okay. So ratios and rates are very straightforward, especially when they're telling you what numbers to put into the actual fraction. So when you start applying them, this is where you need to do a little more thinking. So for example 3, we have a word problem here. It says you have recorded your car mileage and gasoline use for 5 weeks. What was the average mileage for a gallon of gasoline? Round your results in miles per gallon to the nearest tenth. Okay, so we need to look at this table here. We've got the number of miles and we've got the number of gallons. And we want to find the average mileage per gallon. So we need miles per gallon. But we've done this for 5 weeks and we need that average here. Okay, so I need to take a moment and I need to add up all of the miles that I went. And if I add up every week, I'll have 989 miles total. And I need to do the same thing here for the number of gallons. I need to add all these up. And when I do that, I'll have 30.1 gallons that I used in those 5 weeks. So now I can figure out the miles per gallon for that whole time span. So I went 989 miles and I used 30.1 gallons in order to do that. And now I would want to divide. So I would use my calculator, 989 divided by 30.1, and I would get 32.86. But it says to round it to the nearest tenth. So this would actually round up to 32.9 miles per gallon. And we can do MPG because we're really familiar with what that stands for. That stands for miles per gallon. Okay, so this problem had an extra little step where we had to add up our total for a certain amount of time before we could write our ratio. All right, an example 4 now. We're going to do some converting. And if you don't know some common conversion units, I do have them listed down below. And when we do conversions, we're basically just trying to change units from one to another. So we might change seconds into hours, or months into days, or weeks into years, feet into miles. Okay? If you don't know a certain rate, ask and we will tell you. We're not quizzing you on knowing how many inches are in a foot, we're going to be assessing you on how well you can actually do the mathematical calculation to convert. So for part A here, we're going to change 5 minutes into seconds. And we're going to use little fractions to do this. So I'm going to start with 5 minutes. And I don't know why it's making that extra little line. Whoa, what is going on there? And now that won't erase. Yikes. Okay, let's try this again. So we're going to convert 5 minutes into seconds. So I have 5 minutes. And again, I'm going to try thinking of this as like a fraction. So any whole number I can put over 1. And now to change it into seconds, I'm actually going to use the operation of multiplication. And I just have to figure out what I'm going to multiply by. So I have to know how many seconds are in a minute. And you should know that there's 60 seconds in 1 minute. Hopefully you know that. If not, it's listed down there. Okay? Now, here's the trick for setting up a proper conversion with fractions. We need these minutes, this unit of minutes, to cancel. And if I set up another fraction over here, the only way I can get those minutes to cancel is if they're in the denominator in my second fraction. Because when I want to cancel from top to bottom. So if there's 60 seconds in 1 minute, then I need the 60 seconds to be in the numerator and the minutes to be in the denominator. That way I can cancel out that unit of minutes and minutes. And now I just have to take 5 times 60 and I will get 300 seconds. And hopefully you know that if you're changing minutes to seconds, hopefully you know that you need to multiply 60 times 5, 60 seconds times the number of minutes. Okay, so we're still doing that same operation that hopefully you have in mind to do. I just want you to be able to set it up in these fractions. Because sometimes we don't always multiply, sometimes we divide. So when you set it up as fractions so that you can cancel out the unit, you'll be getting the correct mathematical operation every time. So for part B, we're going to change days into weeks. So I'm starting with 98 days. So 98 days, and I'm going to put that over 1. And then I'm going to multiply by another fraction. Now I'd have to know how many days are in a week. And we're assuming that it's a full week. It's not a work week or a weekend. So we're going to assume that there's 7 days in a week. And again, that's listed down below here. Okay, there's 7 days in a week. So if I want the days to cancel when I set up my second fraction, the days are in the numerator, so I need my days to go in the denominator down here so that they will cancel. And there are 7 days in 1 week. So once I know where the specific unit goes, then I can fill in the rest of that fraction. So now the days will cancel. And if I multiply across, I'll really have 98 over 7, and that will divide into 14 weeks. And again, hopefully you would know that if you had 98 days and you were trying to figure out how many weeks that was, I hope you would know you would take 98 divided by 7 to do that. So this is still setting up the same concept, just using fractions to help us do the conversion. Okay, part C, we have 180 inches, and we're going to change that to yards. And I don't know offhand how many inches are in a yard. I do. You secretly could do this in 1 step, but I'm going to show you how to do this in 2 steps. Okay? I might not know how many inches are in a yard, but I know there's 12 inches in a foot. So there's 12 inches in 1 foot. And then there's 3 feet in 1 yard. So I'm going to do a 2-step conversion here instead of just a 1-step. So I'm going to start with my 180 inches. I put that over 1. And then I'm going to change inches to feet. So I want the inches to cancel, so they need to be on the bottom. That means feet need to be on the top. And there's 12 inches in 1 foot. So now my inches will cancel. So now if I multiplied across and divided, I would have my answer in feet. But I still have to change the feet to yards. So I want the feet to cancel, so I'm going to put them on the bottom. I want my answer, my final answer, to be yards, so that needs to go on top. And there are 3 feet in 1 yard. So again, those feet are going to cancel. So now if I multiply all the way across my numerator, I'll have 180. Multiply all the way across my denominator, I'll have 36. And if I divide those out, I'll end up with 5 yards. And there are 36 inches in 1 yard. So when we take 12 by 3, we get the 36. So that's how you could do this problem in one step. You could take 180 over 1 times 1 yard over 36 inches. So if you did know that, you could do that problem in one step. But I wanted to show you how you could do it in multiple steps. And part D is another multiple step problem. We're going to change years to hours. And this one is a little more obvious. I really don't know how many hours are in 1 year. But I do know how many days are in a year, and I know how many hours are in a day. Okay. So there are, oh, it's not actually listed here, but there are 365 days in 1 year. And then there are 24 hours in a day. That one's listed. So we should probably put 1 year equals 365 days. That could be added to our list as well. And so I'm going to use those 2 pieces of information to do this conversion. Again, I'm starting with 4 years. So I'll put that over 1. And then first I'm going to change it into days, and then I'll change days into hours. So I'm kind of going from a big unit down to a smaller unit gradually. So I'm starting with my 4 years, and then I'm going to multiply so that those years cancel. So I need the year to be on the bottom. And in 1 year, there are 365 days. So now the years will cancel. And then I have to go finally from days to hour. Some days has to be on the bottom, hours has to be on the top. And there are 24 hours in 1 day. So then those days will cancel off. And now I can multiply across. If I multiply all the way across, I'm going to get 35,040. If I multiply across the bottom, I just get 1. So I got my answer in one step there. 35,040 hours in 4 years. So again, try setting up those conversion problems with fractions. Set it up so that the unit you're trying to cancel is diagonal. One's in the numerator, one's in the denominator. Make reference of this conversion chart here. And if you have any questions about any of the other conversions, make sure you ask. Okay, so try out these homework problems. And if you have any questions, come on in before school and see me.